Hi guys, welcome to this easy maths video, and today we are looking at the intermediate maths challenge from 2017, questions 11 to 20. Question 11 says the diagram shows four equilateral triangles with side lengths 1, 2, 3 and 4. The area of the shaded region is equal to n times the area of the unshaded region of side length 1. What is the value of n? We've got answers as A is 8, B is 11, C is 18, D is 23, and E is 26. Okay, so we are told that the area of the shaded region is equal to n times the area of the unshaded region. Okay, so the way I thought about this question is I looked at the unshaded region, which is a triangle, which is an equilateral triangle, which looks something like this with side lengths of 1. Okay, and I said we don't know what the area of this triangle is. Let's represent its area with the letter A. Well, then I thought, let's compare this triangle against the equilateral triangle with side lengths of 2. So if I say it looks something like this, that is side length 2, that's side length 2, that's side length 2. Now, what is its area going to be in terms of A? Well, we know if we cut each of the lengths in half, this side length is going to be 1, this side length is going to be 1, that's going to be 1, that's going to be 1, that's going to be 1, that is also going to be 1. So what we can do is we can draw some equilateral triangles with side length 1 within inside this larger equilateral triangle with side lengths 2. What I can do is I can draw a line connecting both of the midpoints, and I know that this triangle is going to have an area A. Then you should be able to see that there's also another triangle here. And then if I connect these two midpoints, I've got another equilateral triangle here with area A and another equilateral triangle here with area A. So the total area of this equilateral triangle is equal to 4A. There's a pattern with this. So if I've got an equilateral triangle with side lengths of 2 and an equilateral triangle with side lengths of 1, what we can say is that the area A is proportional to the side lengths, which I'm going to represent as S, squared. Because the side lengths of this equilateral triangle are 2, and 2 squared is 4. Okay, so what does that mean? Well, that means the triangle with side lengths of 3 has an area of 9A, and the equilateral triangle with side lengths of 4 has an area of 16A. So I can write these on the diagram. I can say this is 4A, this is 9A, and this is 16A. And I know that this triangle, the unshaded region, has area A. Now you should be able to see the unshaded region represents a triangle with lengths of 1 within all three of the triangles. So what that means is the area of this shaded region is 4A minus A, which is 3A. And the area of this region is 16A minus A, which is 15A. And the area of this region is 9A minus A, which is 8A. Now what I can do is I can use this formula that I wrote at the start, saying that the total area of the shaded region is equal to n times the area of the unshaded region. So my total shaded region is going to be 3A plus 8A plus 15A is equal to n times the unshaded region, which has an area of A. So now if I simplify the left-hand side, I'm going to have 3A plus 8A plus 15A, which is 26A, and that's equal to NA. Now both sides of my equation has a constant of A, which cancels out, and I get a value for N of 26, which we've got an answer for, which is answer E. So therefore, our final answer equals E. Question 12. The combined age of Alice and Bob is 39. The combined age of Bob and Claire is 40. The combined age of Claire and Dan is 38. Combined age of Dan and Eve is 44. The total of all 5 ages is 105. Which of the 5 is the youngest? Got answers as A is Alice, B is Bob, C is Claire, D is Dan, or E is Eve. Okay, so the way we can think about this question is we can write their ages as equations. So we can say Alice is A, Bob is B, Claire is C, Dan is D, Eve is E. Okay, so we know Alice plus Bob's age is equal to 39. Then we're told the total of Bob and Claire's age, which is B plus C, equals 40. Then we're told the combined age of Claire and Dan is 38, so that's C plus D equals 38. And then the combined age of Dan and Eve is 44, so D plus E equals 44. And then lastly, we're told the total of all 5 ages is 105. So that means Alice plus Bob plus Claire plus Dan plus Eve equals 105. Now what we can do is this final equation, which is equal to 105, we can replace the values of A plus B and C plus D with the values that we've got up here. So A plus B is equal to 39, C plus D is equal to 38, and then we've got E left over, and that's equal to 105. So now we've got an equation where we can solve for E and work out Eve's age. And then once we've got Eve's age, we can use the formula D plus E equals 44 to work out Dan's age. Then we've got Dan's age, we can work out Claire's age. When we've got Claire's age, we can work out Bob's age. And when we've got Bob's age, we can work out Alice's age. We can compare all the ages, work out which one's the youngest, and then we can find out our final answer. So we simplify the left-hand side, 39 plus 38. That gives us 77. Plus Eve's age equals 105. Now we've got to subtract 77 from both sides, and that should give us an answer of 28. So Eve's age is 28. Now if I use the formula D plus E equals 44, I can work out Dan's age. Dan's age is going to be equal to 44 minus Eve's age, which is 28. 44 minus 28 is 16. Claire's age is going to be 38 minus Dan's age, which is 16. 38 minus 16 is 22. Now Bob's age is going to be 40 minus Claire's age, which is 22, and that's going to give us an answer of 18. And then Alice's age is going to be 39 minus Bob's age. 39 minus 18. 39 minus 18 is 21. And now we just look at all of the ages, see which one is the youngest, and that is our final answer. So Eve is 28, Dan is 16, Claire is 22, Bob is 18, Alice is 21. So the youngest of the 5 is Dan, who is 16. So therefore, our final answer equals D. Question 13. The diagram shows a quadrilateral PQRS made from 2 similar right-angled triangles, PQR and PRS. The length PQ is 3, the length QR is 4, and angle PRQ is equal to angle PSR. What is the perimeter of PQRS? We've got answers as A is 22, B is 22 and 5/6, C is 27, D is 32, E is 45 and a third. Okay, so the key to this question is knowing that PQRS is made from 2 similar right-angled triangles. Okay, so what I'm going to do is I'm going to draw a diagram for triangle PQR and another diagram for PRS. So we say this is P, this is Q, this is R, this is our right angle. And this is going to have a length of 3, and this side is going to have a length of 4. PRS, say something like this. We can call this P, we can call this R, this S, and this can be our right angle. Right, so you should be able to see that the length PR is on both of the triangles. And we can calculate PR easily, because for this triangle, PQR, it is our hypotenuse. So we can use Pythagoras to work out that length. So we can say PR is equal to the square root of 3 squared plus 4 squared, square root of 9 plus 16, which is square root of 25, which is equal to 5. Okay, so this length is 5, so it means that this length is also 5. Now, for two triangles to be similar, what it means is all of their angles are the same, but their lengths can change. So what that means is each of these lengths, so the hypotenuse, the base, the height of the triangle of PRS is proportional to the triangle PQR. So what we're basically saying is if we look at the bases, for triangle PQR we've got a base of 3, and for triangle PRS we've got a base of 5. So to get from 3 to 5, we're going to multiply 3 by 5 over 3, because that's going to give us an answer of 5. So multiplying by 5 over 3 is what we call our scale factor, and we can apply that scale factor to each of our lengths. So if I want to find what the length of RS is, I can say that RS is equal or is proportional to the length RQ, which is 4, and then I can multiply that by my scale factor, which is 5 over 3. Now this simplifies to 20 over 3. And then to find PS, well, the length PS is proportional to the length of PR. So I can find PS by doing the length of PR, which is 5, multiplied by my scale factor, which is 5 over 3. And that simplifies to 25 over 3. Okay, so now I've got these two lengths. I've got PS, which is 25 over 3, and I've got RS, which is 20 over 3. Okay, and I can also add these lengths to my diagram PQRS. So we said RS is 20 over 3, and this is 25 over 3. Now I've just got to find the perimeter of PQRS, which is adding up all of the lengths. So that means PQRS is equal to 3 plus 4 plus 20 over 3 plus 25 over 3. Now 3 plus 4 is 7. 20 over 3 plus 25 over 3 is 45 over 3. Now 45 over 3 simplifies to 15. So PQRS is equal to 7 plus 15. And 7 plus 15 is equal to 22. So 22 is our perimeter, and we've got an answer of 22, which is answer A. So therefore, our final answer is A. Question 14. For what value of x is 64 to the power of x equal to 512 to the power of 5? We got answers as A is 6, B is 7.5, C is 8, D is 16, and E is 40. So we've basically got the equation 64 to the power of x is equal to 512 to the power of 5. So the way I thought about this is I looked at the bases. So we've got 64 and 512. And what we need to think is, what power do I need to raise 64 to in order to get 512? Obviously, I know 64 to the power 1 is 64, so x must be greater than 1. What about if I square 64? If I square 64, is it going to be bigger than 512? Okay, so what I can do is I can draw a grid. I can do 60 times 60, which is 3,600. 60 times 4, which is 240. 60 times 4 again, which is 240. And 4 times 4, which is 16. Add these all together. So that gives me an answer of 6. 4 plus 4 plus 1 is 9. 6 plus 2 is 8, plus 2 is 10, so that's 0. Carry the 1. Get 3 plus 1 is 4. So if I just move this over here, 64 squared is equal to 4,096. Now, 4,096 is obviously greater than 512. So that means x has to be less than 2. So I can write my values of x, saying that it's between 1 and 2, like this. So what I'm going to do is I'm going to test for different values between 1 and 2 until I get an answer of 512. So I'm going to start with taking the average of 1 and 2, which is 3 over 2. So if I say that x is equal to 3 over 2, that's exactly halfway between 1 and 2. And let's see what happens when I do 64 to the power 3 over 2. Well, to get that, what I need to do is this is the same as saying the square root of 64 cubed. Well, the square root of 64 is 8, and 8 cubed is 8 times 8, which is 64, and then 64 times 8. Now, 64 times 8, that's 8 times 4, which is 32, and 8 times 60, which is 480. Add these together, get 2, I get 3 plus 8, which is 1, carry the 1, and I get 1 plus 4, which is 5. So here, I get an answer of 512. So what this means is that 64 to the power 3 over 2 equals 512. Okay, and we're told what value of x is 64 to the power of x equal to 512 to the power of 5. Okay, so rather than saying 512 to the power of 5, we could say 64 to the power of 3 over 2 all to the power of 5. And now I'm using the law of indices. If we've got a power inside a bracket and we've got another power outside of the bracket, we multiply the two powers together. So this is going to give us an answer of 64 to the power of 3 over 2 times 5, which is 15 over 2. And 15 over 2 is 7.5. So x is equal to 7.5. We've got an answer for 7.5, which is B. So therefore, answer equals B. Question 15. In the diagram shown, PQ is equal to SQ, which is equal to QR. And angle SPQ is equal to 2 times angle RSQ. What is the size of angle QRS? Got answers as A is 20, B is 25, C is 30, D is 35, and E is 40. Okay, so what we've got here is we've got two triangles, SPQ and QRS, which are two isosceles triangles. Okay, and we're told SPQ, which is this angle, is equal to 2 times RSQ. So RSQ is this angle. So we say RSQ has a size of angle X, then we can say that angle SPQ has a side angle of 2x. Now, because both of these triangles are isosceles, and we're told that SQ is equal to PQ, so they have the same side lengths, that means they're also going to have the same angles. So the angle PSQ is also going to be equal to 2x. Now, and the same can be said with the triangle QRS, because QS is equal to QR. So that means that the angle QRS is also going to be x. And now what we can do is we can say, well, the angle S is going to have a total of 3x, 2x plus x. We can generate an equation to find x and work out the value of QRS by adding up all of the interior angles and then making it equal to 180 degrees. So we can say that 2x plus 3x plus x is equal to 180. So we simplify the left hand side. We're going to get 6x equals 180. Then we can divide both sides by 6. So we get x equals 180 over 6, which is 30 degrees. And QRS is equal to x. So QRS must also be equal to 30 degrees. We've got an answer of 30 degrees, which is answer C. So therefore, the final answer is C. Question 16. The product of two positive integers is equal to twice their sum. This product is also equal to 6 times the difference between the two integers. What is the sum of these two integers? We've got answers as A is 6, B is 7, C is 8, D is 9, and E is 10. Okay, so what we can do is we can represent the two positive integers with the letters X and Y. Okay, and the first thing we're told is that the product of the two positive integers is equal to twice their sum. So the product is multiplying x and y together. So we say xy is equal to twice their sum. So that's saying 2 multiplied by their sum, which is x plus y. Okay, so we can say this is our first equation. Then we can form a second equation by looking at the next statement, which says this product is also equal to 6 times the difference between the two integers. So it's the same product, xy, and that is equal to 6 times the difference between the two integers. So that's a 6 all multiplied by x minus y. Now, it doesn't matter which way around you put x and y, because we don't know what the values of x and y are. So it doesn't matter if you say we've got 6 multiplied by y minus x, or we've got 6 multiplied by x minus y. It doesn't matter. So that's our second equation. Now, what you should be able to see is the product xy is equal to this value, and it's also equal to this value. So what we can say is that 2 multiplied by x plus y is equal to 6 multiplied by x minus y. Okay, so if we expand the brackets, we're going to get 2x plus 2y is equal to 6x minus 6y. And then what I could do is I could subtract 2x from both sides. So I get 2y equals 4x minus 6y. And then I could add 6y to both sides. So I get 8y equals 4x. Now I can solve for either x or y. It doesn't really matter. I'm going to solve for x so I can divide both sides by 4. So if I divide both sides by 4, I'm going to get 2y equals x, okay? Now what that means is I can go back to either of these equations. So I can now replace x with 2y. So if we have a look at the first equation, I'm going to have 2y multiplied by y, which is 2y squared. Okay, so we got 2y squared is equal to 2x plus 2y. So we can replace x with 2y. So that's going to be 4y and then plus 2y. Now, and if we simplify this, we're going to get 2y squared is equal to 6y. Divide both sides by y, we get 2y is equal to 6. And then we can solve and get y is equal to 3. And then, because we've got this equation, 2y is equal to x, we can easily work out x by saying that x is equal to 2 times 3, which is 6. But the question said to work out what the sum of these two integers are. So the sum is x plus y. Well, x plus y is going to be equal to 3 plus 6, which is 9. And we've got an answer for 9, which is answer D. So therefore, final answer is equal to D. Question 17, the diagram shows two rectangles and a regular pentagon. One side of each rectangle has been extended to meet at x. What is the value of x? Got answers as A is 52, B is 54, C is 56, D is 58, and E is 60. Okay, so the first thing we need to do is we need to work out the interior angles of this pentagon. So we can work out the exterior angles by doing 360 degrees divided by the number of vertices, or the number of edges, which is 5. And that gives us an answer of 72. So the interior angle is going to be 180 degrees minus the exterior angle, which is 72. So that's 108. So look at these angles here. That angle would have been 72, and this angle inside here is 108. Same with this angle, same with this angle, same with this one, and finally same with this one. Okay, what I want to do is I want to focus in a bit more here. Now, what you should be able to see is, because we've got a rectangle up here, the interior of the rectangle is going to be 90 degrees here. And this whole angle is 108 degrees. So the angle between pentagon and the rectangle, so this angle here, is going to be 108 minus 90, which is 18 degrees. Okay? Now we know what this angle is because we just worked it out. It's the interior angle of the pentagon, which is 108. So we can work out this angle here. And this angle here, well, we've got a triangle here, so we can say 180 minus 18 minus 108. Now minus 18 minus 108 is minus 126. And 180 minus 126 is 54. So that's going to be 54 degrees. Now, and another thing you should be able to see is this a line that has extended from the rectangle and then continues down to the point X. Well, that intersects one of the sides of our pentagon. Okay? And we've got two different angles here. We've got the angle that we just calculated, which is 54, and then we've also got this angle here. Well, what you should be able to see is that these two angles are going to be the same, which means that the angle which we've calculated as 54 degrees is going to be equal to this angle here. So this angle is also 54 degrees. Now, what else do we know? Well, here we've got another rectangle, so these are going to have interior angles of 90 degrees. So we can work up this angle here. So if I work it out here, we need to do 360, take away 108, take away 90. And that gives us an answer of 162. So this angle here is 162. And then, well, this angle here is just going to be 90 degrees because it's on a straight line. The interior angle of the rectangle is 90 degrees. So that must also be a right angle there. So now we need to work out x. This shape here that I'm highlighting, you should see has four edges. It's a quadrilateral. And the sum of the interior angles within the quadrilateral add up to 360 degrees. So I can work out x by forming an equation and saying that x plus 90 plus 162 plus 54 is equal to 360. Make these all degrees. Now 90 plus 162 is 252 plus the 54 equal to 360. 252 plus 54 is 306. And that's equal to 360. So I now need to subtract 306 from both sides. And I get an answer as x is equal to 54 degrees. So we've got an answer as x is 54 degrees. And we've got an answer of 54 degrees, which is answer B. So therefore, final answer equals B. Question 18. A water tank is 5/6 full. When 30 litres of water are removed from the tank is 4/5 full. How much water does the tank hold when full? We've got answers as A is 180 litres, B is 360 litres, C is 540 litres, D is 720 litres, and E is 900 litres. Okay, so what we need to do is we need to basically form an equation based on what we're told. Let's say that when the tank is full, so when the tank is full, the tank can hold X litres, okay? Now, our water tank at the moment is 5/6 full, so in other words, it's 5/6 of X. And we're told when 30 litres of water are removed from our tank, the tank is now 4/5 full. So if we subtract 30 from 5/6 of X, that's going to be equal to 4/5 of X. And that's it. We've got an equation. Now we just need to solve for X. So what we can do is we can multiply both sides of our equation through by 6. Okay, so we're going to get 5x minus 180 is equal to 24 over 5x. Now what I'm going to do is I'm going to multiply through by 5 to get rid of the 24 over 5x. So I'm going to get 25x, and I'm going to get 180 multiplied by 5. 5 times 80 is 400, and 5 times 100 is 500, so that's going to be minus 900. And that's going to be equal to 24x. Now what I can do is I can subtract 24x from both sides. So I get x, and then I can add 900 to both sides. So I'll get x equals 900. And that's when the tank is full. So when the tank is full, it can hold 900 litres. And we've got an answer for 900 litres, which is E. So therefore, final answer is equal to E. Question 19. PQRS is a square. Point T lies on PQ so that the ratio of PT to TQ is equal to the ratio of 1 to 2. Point U lies on SR so that the ratio of SU to UR is equal to the ratio of 1 to 2. The perimeter of PTUS is 40 centimetres. What is the area of PTUS? We've got answers as A is 40 centimetres squared, B is 45 centimetres squared, C is 48 centimetres squared, D is 60 centimetres squared, and E is 75 centimetres squared. Okay, so I think the best way to answer this question is to draw a diagram. So we know we've got a square, PQRS. We draw this square, and so that's something like that. We can then annotate point T on the diagram. Now, point T lies on PQ, so that the ratio of PT to TQ is equal to 1 to 2. So in other words, what we're saying is, let's say T's here, we're saying that the length PT is equal to a third of PQ. Okay, so PT is a third of PQ, which means that TQ is going to be 2/3 of PQ. Now, we're also told that point U lies on SR, so that SU to UR equals 1 to 2. Okay, so this is the same ratio. So what we're saying here is that SU is equal to a third of SR. Now, what I'm going to do is I'm going to switch my R and S round. It doesn't really matter, because it's a square, you know, all of the side lengths are going to be equal. But what it means is that I can annotate point U so it's exactly parallel to point T. And that's really going to help me solve this question. Okay, so let's say that the side lengths of this square are length X. Okay? Now, if PT is a third of PQ and SU is a third of SR, then surely this length is going to be a third of X, and this length is also going to be a third of X. So what we've got here is, if I join T and U, we've actually got a rectangle that has a width of a third of X and a height of X. Now, we're told that PTUS has a perimeter of 40 centimetres. So we've got our side lengths in terms of X. So what we can say is that we can do X plus a third of X plus a third of X plus X is equal to 40. Now, if we simplify the left-hand side, we're going to get 2X plus 2/3 of X is equal to 40. Okay, so if I rewrite 2x as 6/3x, and plus 2/3x equals 40, then we can simplify the left-hand side and get 8/3x equals 40. Okay, so now I should be able to solve for x. I can multiply both sides by 3, and I get 8x equals 120, and I can divide both sides by 8. So x equals 120 over 8. So we know that 120 over 4 is 30. Divide 30 by 2, we're going to get 15. So x is 15. And we want to find the area of PTUS. So if x is 15, we will replace this with 15. And then if SU and PT are a third of 15, because they're a third of x, I'll replace this with 15. And I can replace PT and SU with 5. A third of 15 is 5. And now all I'm doing is I'm doing the area of this rectangle here. So it's just 5 times 15. The area equals 5 times 15, which is equal to 75. Of course, that's going to have a unit of centimetres squared. We've got an answer of 75 centimetres squared, which is answer E. So therefore, that is our final answer. Question 20, the diagram shows 7 circular arcs and a heptagon with equal sides but unequal angles. The sides of the heptagon have length 4, the centre of each arc is a vertex of the heptagon, and the ends of the arc are the midpoints of the 2 adjacent sides. What is the total shaded area? We got answers as A is 12 pi, B is 14 pi, C is 16 pi, D is 18 pi, and E is 20 pi. Okay, so with this question, we are trying to find the total area of all 7 circular arcs. Now, to find the area of one circular arc, what you're doing is, let's say we have a look at this arc here. You need to know what this angle is. Okay, so I'm going to call that angle theta. Okay, and there's a formula from GCSE Maths that you should have came across, which is the area of a sector and it's equal to theta divided by 360 degrees multiplied by the area of the circle, which is pi r squared. You're basically working out the area of the circle based on a proportion of the angle, and you can work out that proportion by doing theta divided by 360. Okay, so that's a formula that we need to know. But how are we going to find out what theta is? First of all, we're told that in the question, the heptagon has equal sides but unequal angles. So all of these angles here, all of its interior angles are completely different, okay? But we can still work out what the sum of those interior angles is going to add up to. So I think the best way to do this is to work out how many triangles we can find within this heptagon. So there's going to be one triangle there, another triangle where it intersects that vertex, another triangle here, another triangle here, and that's it. So we've got 1, 2, 3, 4, 5. We've got 5 triangles, and we know that the interior angle of a triangle adds up to 180. If I write here, interior angles of a heptagon equals 180 times 5. So remember, that's 5 times 80, which is 400, 5 times 100, which is 500, add them together, sum of the interior angles is going to equal 900. Now there is a formula that you could use to remember that, and I think it's worth remembering. Basically, for any polygon, we say that a polygon's got n sides, then the total number of triangles, if we represent that with t, is going to be equal to the number of sides n minus 2. So the number of triangles within a polygon is always going to be 2 less than the number of sides of your polygon. And then of course you would just multiply n minus 2 by 180 to work out the sum of those interior angles. So we know the sum of the interior angles is 900 degrees. Now what that means is we can work out the sum of all the exterior angles. Okay, and the way we can do that is we can say, well, if we look at one of these arcs, we know that the interior angle plus the exterior angle is going to be a full circle, which adds up to 360 degrees. So if one circle is 360 degrees, the total angles of 7 circles is going to be 360 times 7. Now 7 times 60 is 420, and then 7 times 300 is 2,100. So add those, we are going to get 2,520 degrees. So to find the exterior angles, well, we know the interior angles add up to 900, so if we do 2,520 minus 900, that's going to give us 1,620. That is going to be the sum of our exterior angles. Now, if we come back to this formula, theta over 360 times pi r squared, well, theta is going to be equal to 1,620 because that is the sum of the whole exterior angles. You know, we don't have to say theta is just equal to one angle, we can say it's equal to all 7 angles. Now, we don't want to do 1,620 divided by 7 because we know that each of the angles are of a different size. But if we just treat all 7 angles together as 1,620, then what we can do is we can do 1,620 divided by 360 and then multiplied by pi r squared. Now we're told that the sides of a heptagon have length 4. Okay, so each of these side lengths are 4. The ends of the circular arcs are the midpoints of the 2 adjacent sides. So what that means is that these arcs have radiuses of 2. Okay, so we're going to multiply by pi multiplied by 2 squared. Now, how are we going to solve 1,620 divided by 360 without a calculator? Well, let's think of the 360 times table. So we're going to have 360 times 1, 360, 360 times 2 is 720, 360 times 3 is going to be 1,080, 360 times 4, 1,440. 360 times 5 is going to be 1,800. Okay, so 1,620 is somewhere between 1,440 and 1,800. Now let's check whether it's exactly halfway. I think that's the best test to do first. So we can do 1,440 plus 1,800. That's 3,240. And then divide that by 2. It's going to be 1,620, which is what we've got here. So if this is between the 4th and 5th value, then this must be 4.5. Okay, so we're doing 4.5, which I'll write as 9 over 2, times 4 pi, which simplifies to 18 pi. We've got an answer of 18 pi, which is answer D. So therefore, our final answer is D. Thanks for watching the video, guys. Don't forget to subscribe to my channel. I've also left a link in the description to my website, and you can also check out any other videos from my YouTube channel on this page.